Good afternoon, everyone. I'm Mike Steves. I'm the Program Manager for the Canadian Sea Lamprey Control Program, and on behalf of myself and fellow Technical Committee member Jess Barber, who is the Field Supervisor for the U.S. Sea Lamprey Control Program, I'm here today to present the highlights of our program on Lake Superior for the past year. To do so, I'll first cover the fish community objectives specific to sea lamprey, and along with how the FCOs have been adapted to numerical targets for both abundance and damage to lake trout. I'll cover the program elements as they were deployed during 2021, show where we stand in relation to the FCOs and targets through our usual time series of Sea Lamprey index and marking rates. Then lastly, I'll briefly cover plans for the coming year. With regards to the fish community objectives, in 2003, Horns et al. Published the fish community objectives for Lake Superior, including the one for sea lamprey. This FCO is expressed as suppressing sea lampreys to population levels that cause only insignificant mortality on adult lake trout, and more explicitly, to suppress populations until annual lamprey-induced adult lake trout mortality is essentially insignificant or less than 5%. In 2004, the Lake Superior Committee agreed to explicit suppression targets defined during a time when sea lamprey abundance and associated damage to lake trout were considered to be at tolerable levels. Explicitly, the target for sea lamprey wounding, a surrogate for sea lamprey-induced mortality, is to not exceed 5 A1 to A3 wounds per 100 lake trout larger than 532 millimeters, or about 21 inches. The target for sea lamprey abundance, as evaluated by the network of index streams in Lake Superior, is 10,420 sea lampreys annually. This target for adult sea lamprey is based on a 5-year period when the time series for sea lamprey wounding, which 1994 through 1998, when marking rates were closest to the 5 marks per 100 lake trout of the specific size. So what did we do in 2021 to aim to meet targets and fish community objectives? This map illustrates what we were able to accomplish last year, with the red dots representing treatments that were completed and blue dots those that were planned but unable to be undertaken. Unlike 2020, 2021 provided more opportunity to conduct program operations during the pandemic. Nevertheless, typical challenges such as insufficient discharge in a number of rivers affected the ability to conduct lampricide applications in a number of tributaries and mainly on the Canadian side of the lake. This means that during 2021, program staff were able to complete a total of 23 of 36 planned treatments in our control effort. And this is a time series of the number of lampricide applications to Lake Superior since 2000. TFM applications are represented in the yellow portion of the bars, and the lentic treatments are the red portions. If you recall, last year, Sea Lamprey Control was impacted by the need to keep staff safe during the pandemic, and lampricide applications were only able to be completed in rivers that were in proximity to control agent headquarters. Combined with the unfavorable environmental conditions in about 1/3 of the streams in 2021, this has resulted in a number of lampricide applications being below the long-term average over the past 15 years. But in an upcoming slide, I will talk about plans for 2022 and the planned increase in the number of lampricide applications. Besides lampricide applications, which remain the most widely used method of sea lamprey control, the use of barriers to sea lamprey migration is the only proven alternative that can obtain success equal to or exceeding the application of lampricides. The Sea Lamprey Control Program maintains a series of barriers throughout the Great Lakes, 18 of which are in the Lake Superior Basin. The use of barriers follows an established protocol that describes how sea lamprey barriers are identified, maintained within the program, and also criteria for constructing new barriers where use is cost-effective, provides additional control benefits, and fits existing watershed management plans. This slide shows the distribution of the 18 barriers presently an active part of Sea Lamprey Control in Lake Superior. In 2020 and again in 2021, all barriers were operated throughout the sea lamprey spawning migration, and the barrier program was able to undertake a number of additional tasks, including consultation with the Bad River Tribal Council regarding barrier sites on the Bad River, continuing to work with the U.S. Forest Service to identify suitable sea lamprey barrier sites on the Ontonagon River, consultations on 9 barrier removals or remediations in 6 tributaries, begin planning trap replacement on the Nebing River, and remediations and repairs to barrier sites throughout the basin, including collaboration with Wisconsin DNR on repairs to the Brule River Fishway. All told, it was a very successful 2021 with respect to barrier operations on Lake Superior. I'd also like to bring some attention to some research that is being led by Nick Johnson at Hammond Bay Biological Station. Although the 2 primary means of control, lamprey applications and barriers, remain very effective, sea lamprey still survive or avoid treatments and can still exceed targets in some lakes. Supplemental control is aimed at providing additional means to address this source of recruitment through stream and situation specific techniques like sterile male release, use of attractants and repellents, electrical guidance, collection of newly transformed sea lampreys, and other means. This research has been ongoing for a couple of years and will continue for several years into the future as a longer-term investment into better understanding of how additional means to control sea lamprey might be employed. This is sort of a stay-tuned piece of information for everyone, and we will build on it over the next few years. The Adult Assessment Program provides marker capture estimates of sea lamprey in select streams as an evaluation of program success. In Lake Superior, 11 streams were trapped during 2021, 7 as part of our index network, and 4 as part of ongoing arrangements to operate traps, remove sea lampreys from the spawning population, and to pass fish above other fish species above barriers. As part of this network, adult sea lamprey migrations were assessed in the Bad, Brule, Fire, Steel, Middle, Misery, and Silver rivers through cooperative agreements with Gliffwick and Keweenaw Bay Indian Community. Although traps were operated in the Nebing River, insufficient recaptures of marked sea lamprey did not yield a marker capture estimate, and the index was modeled for this stream. So as you can see on the slide, the 2021 index for adult abundance in Lake Superior is 27,174, which is about 3 times the index target. The 2021 estimate is plotted as part of the time series in the upper right panel on this slide. Recall that we were unable to estimate the index during 2020, hence the break in the time series for that year. As you can see, although not as high as the index estimate since about 2012, the number does exceed the target by about 3-fold, as I mentioned. Similar to the adult index, data used to estimate lake-wide marking rates was challenging to gather during 2020, and the modeling group felt that it was not appropriate to use what little data that could be provided to create a point for Lake Superior for that year. And although data for 2021 was collected, the information is still being assembled for all lakes and is not yet available. It will be published on the Great Lakes Fishery Commission website when it is, and in the meantime, the number of A1 to A3 marks on lake trout from spring assessments was 5.7 marks per 100 lake trout, last time calculated in 2019. So that brings us to 2022. Sea Lamprey Control has certainly faced challenges over the past 2 years, from implementing a field program during a pandemic to dealing with environmental challenges. Once again, we're building on the lessons that we've learned to develop plans for a 2022 field season that includes operation of all barriers and traps around the lake, and continued coordination and consultation with other fishery management agencies. Although this last bullet is the first mention of the larval assessment portion of our program in this presentation, I would be remiss if I did not mention the exceptional effort that's put forward by this group from both control agents in being incredibly adaptable in completing assessment duties throughout Lake Superior. Similar to past years, they plan to evaluate larval sea lamprey populations in Lake Superior and throughout the Great Lakes Basin to evaluate stream-specific successive control actions and to be able to evaluate and prioritize streams for lampricide application in 2023. And lastly, with regards to lampricide applications planned for 2022, this includes a full suite of lampricide applications commensurate with years prior to 2020, including 38 lampricide applications and 14 lentic area treatments. And a number of these treatments are the rivers that we did not complete during 2021. So that's a very brief summary of Sea Lamprey Control in Lake Superior during 2021 and a glimpse at plans for 2022. Thanks for the opportunity to present this information, and I'm available to try and answer any questions.